Okay, welcome back everyone. So today I'm making a new video, and basically I've just been working on this simple LaTeX document here, and it's nothing too special. It's just code in LaTeX, obviously, and I was just messing around with some mathematical operations, and it kind of became like a full-scale operation here, where I just started like writing down some interesting problems. There's some calculus up here, just like one problem, and then some linear algebra. It's really random stuff. It's not supposed to be homework. It's just I'm just doing this for fun, and I'm using Overleaf if you're interested. So this is just a really nice way to code in LaTeX from time to time without having to download an actual editor on your computer. So this is pretty nice, and the result is still very beautiful in my opinion. So here's all my code. There's quite a bit of it, as you can see. You know, some of the errors I just ignore because, to be frankly honest with you, I don't know what \hbox badness 10,000 means. So, yeah, there's that. So here are all my packages. These are my packages, or sorry, these are my packages. So I use graphics, which I never actually used. I just had that there because why not? Text I did use. Geometry I'm pretty sure I didn't. I mean I did the margin. I used this to have like a 1-inch margin here. Then PGF plots I did use. Fancy headers, as you can see I did use here. Mr. K, I had my real name up there, but I didn't want to use it because you never know. Also, TA Mr. Dog and Class A4 Calculus, just ignore that. I made that up. Trust me, it's not real. Okay, ASM Math, you always need that for the nice math that you have access to in ASM Math. ASM Sim, to be honest, I don't really know what this does. I mean, I'm assuming it's just like displays mathematical symbols, but it seemed useful, so I just put it there. And then this was default. That was just there. Babel. Yeah, everyone uses that, right? And then obviously this is necessary. I just have 12-point font, and I set it to letter paper. So yeah, so page style fancy, and I just renewed some commands. Here are some of my commands. Just ignore this. I really wasn't. I'm sorry. I wasn't meaning anything bad. I just wanted to shorten the command because /t was already taken. So just ignore that. And then new command bd text bf. So there we go. And here's my header. So I just had to basically get rid of all the default headers by just setting this to fancy href. So that removes the default headers, and I added my own here. And then my footer was just page and then the page number, which is right here. I could center it if I wanted to, but I don't need to, it's fine. And finally I began the document, so my paragraph. Here's just a basic calculus problem, the derivative of this function here. Just use the summation property, just distribute the derivative basically, and take the derivative of each of the elements and evaluate that. And I used the frame box command to box up my answer here, and I think that's pretty nice. Here my formatting was not as nice as it eventually became like near the end here, just so don't mind that. It's kind of all over the place for this calculus section, so the power rule, of course. And this was just a multiple choice question, which asked, which of the following vectors are perpendicular to this vector x? I did go over this in one of my other videos about angles between vectors. So that was pretty interesting. It's basically the key idea is that if you take the dot product of two vectors and that equals 0, then those two vectors are perpendicular to each other. and in some cases they're orthogonal. And here was just giving you the definition, and I actually used a few methods to calculate this. So I didn't only use the generic dot product method, which everyone uses. I also used the fact that we can also consider two vectors to be perpendicular if their slopes are perpendicular, so by graphing them. And that's an interesting way of thinking about it, in my opinion. So there's that. And I could have just gotten rid of these annoying point things, but I decided not to because that command is a bit tedious to write out. So if we calculate the slopes, yeah, you get the idea. I'll put the link in the description so that for those of you who want to just review this document in detail, and yeah, you can comment on it if you'd like. And B, basically section B, this was section A, right, just like right here. And another linear algebra problem. It's just proving that multiplying a set of three n by n matrices is associative. I don't need to add this. I could have just said that multiplying matrices is associative. That's all I had to put, but oh well. I could edit this right now. I guess I should, to be honest. So I should have, I don't know. Okay, so here I started just talking about linear transformations. Since I just felt like, explaining linear transformations in depth, I just started it. So yeah, because that's fun. So I finally finished that. I finally finished the problem. So yeah, let me just edit this real quick. And I think in the future I'll make some videos where I'm just adding on to this document and I'm not talking much, because that might be interesting. I don't know. Probably won't be interesting to you, but it's kind of fun to watch that, in my opinion. Okay, where's this? Okay, prove that multiplying a set of n by n matrices, multiplying matrices is associative. That should look nice. Let's see. Oh, I gotta. Okay, yeah. Just don't worry about that annoying error. Okay. Okay. Prove that multiplying matrices is associative. Yep. That looks great. Okay, and then I kind of have to edit this. Let's take a set of 3 matrices to be okay. Oh, that should work fine. Let's just run that code. And there we go. This is the statement that I proved, and I just explained linear transformations because we'll do a video on solely linear transformations, and I'll just make it clear in that video that if you want an even more in-depth explanation, you can just go to my document here and just read about them. I guess that's kind of cool how I did this. So here's just describing basically 2 consecutive transformations, which is just in 2 dimensions, which is just 2 consecutive 2 by 2 matrices being multiplied by one another. And yeah, that just gives you something called a composed matrix. We'll go into that later. Here's basically the definition of matrix multiplication, which you can get from linear transformations. And yeah, here we finally proved it. And it was just a visualization proof. That's all it was. It's pretty basic. Okay. Well, that's actually about it for this document. Don't worry, we'll expand on it later on. I'll expand on it later on. So 5 pages, not bad in my opinion. And yeah, I just basically learned how to code in LaTeX because it's pretty fun. And I kind of want to show you something else. problem is that this includes my name, so I don't know what I'm gonna do. Let's see what I can do. Okay, unfortunately I can't pause the recording, which is kind of disappointing. But oh well. Maybe I'll just like, I have no clue. Okay, I'll just scroll down quickly. Okay, I guess that works. And then what I can do, oh yeah, okay, well I can reveal my face because this was basically for a science project. Look at me over there. It's pretty funny, but yeah, I've already showed my face like a lot in this channel, so it doesn't really matter, right? There's really no point in worrying about that. Okay, by Mr. K, right? Totally. So there we go. Run by Mr. K, perfect. I just need to run it again so it can render the space. Okay. So here's the date today. Alright, introduction. Okay, introduction. The following is a brief summary of my experiment, including my hypothesis, my graph data, my observation, my conclusion. So this is an experiment that I conducted, and obviously I kind of was a bit extra here, simply because you didn't have to code out your own document, but I wanted to do this just because it seems kind of cool. Right, here I just graphed my data, then I found approximate a line of regression, and here is my line of regression. Obviously it takes this form. It's a linear line. And here's my data in real life, because I'm not much of an experimental person, so as you can see, my data organization is not very good on paper. And here I just showed that the slope here is greater, and that proved my hypothesis. And the conclusion is not very crazy either. It's just a pretty short conclusion. So honestly, that's about it, to say the least. My hypothesis. You can read over this if you want. I'm not going to post a link in the description because it's not very interesting. I thought it was kind of cool how I did this, because just like not for fun, but because it was for an assignment. So I just got that nice feeling. So yeah, you can just read. I'm just not going to post it in the description, like I said. So yeah, that's about it for this video, I think. This was just a quick update, and just to show you something cool that I've been working on. So yeah, hope you enjoyed, and I'll see you in the next video. Goodbye. Oh yeah, and here's my code. So it's basic. Okay, goodbye.